Hello, ladies and gentlemen. Welcome back to my tutorial series. So we are going to finish our arrow system so we can fire some arrow. So in our script folder, we are going to go into the weapon folder. We're going to right click, and this time you're going to create another script, and you're going to name this script arrow. Okay, so we're going to create an arrow script. Then we are going to double click the script and open it up in Visual Studio. Alright, so we're going to finish it up so we get everything working nice and smooth. You could see in the previous video we had a setup where in Unity you can actually so let's play the game. Yeah, so we had this setup where you could actually aim, and the cursor, everything shows when you click, you pull, but when you release, the arrow doesn't move towards the target. We are not firing the arrow, so we're going to do that, yeah, in this tutorial. So let's go back to our script. Now in this script, all we are going to do is right here, let's take away update. We are not going to need updates. We are going to do on collision enter, the on collision enter Unity event. They are going to say when we collide with an object, first we are going to do a check. We are going to do we are just going to first and first is we have to get some few components. So first we are going to get we are going to have a rigid body attached to our arrow. So we are going to say rigid body RB. So right here we are going to say RB dot get component, and then we are going to get the rigid body component. So rigid body, and here we go. So it should be RB is equal to, not dot get component. So you say RB is equal to, yeah. Then the next thing is we are going to get our collider. So we'll be using a box collider. So so you're going to get a box collider component, and we're going to name this guy BX for our box collider. Now we are going to say our box collider BX is equal to, we are going to also get the box collider component. So we are going to say box collider. So we get the box collider component. After getting the box collider, we are going to do something in this call. So on collision enter, the first thing we are going to do is we are going to say RB dot is kinematic should be true, and then the next one is we are going to do bx dot is trigger to be true. Okay, so now when our arrow flies and then impacts, okay, so this on collision enter is going to look for collisions. So when our arrow collides with any object in our scene, we want the kinematic property of the rigid body component to be set to be true, and we want the both collider to be trigger. Okay, so let's go back to our bow script, and now you see we have the arrow prefab here. We taken the game object we want to instantiate. So what we are going to do actually is we are going to change this to a type of rigid body. Okay, so we want to instantiate and then get the rigid body component, and we are also going to change the current arrow, this guy, to also rigid body. Okay, so yeah, so we have that setup complete. So the next thing is to create some function over here to fire the arrow. So I'm going to create a public void, and I'm going to call this function fire. So this is going to actually fire the arrow. So the function is going to take a vector 3, and this vector 3, and that's going to be a direction for our arrow. So the direction of travel for our arrow. So over here we are going to do the current arrow should be equal to instantiate. We are going to instantiate an arrow. We are going to do both settings dot our arrow prefab. Okay, so we are instantiating our arrow prefab, and we want to instantiate it in the bold settings dot arrow pose. Okay, so where exactly we want to instantiate this game object. So we are instantiating it at the bold settings arrow pose transform we created. Okay, which is storing the transform of where our arrow should be located, and then the rotation. Then the next thing we are going to do actually is we need to say we want this to be instantiated as a rigid body, so we can get the rigid body and store in this current arrow variable here. Now after the instantiate is complete, we need to actually apply our force, our physics force. So we'll do a current arrow. So current arrow dot add force. Okay, so this is a rigid body, so we can apply force on this object. So we are going to add force, and then we are going to take the direction for our force, and then the next thing will be the force amount. Okay, the amount of power for this force. So in our arrow settings we are going to create a float. So we are going to say public float, and we are going to say arrow force. So this is the force at which the arrow is going to travel. So let's set it to, let's say 3 for now. Okay, so we are saying the arrow force is 3. We are going to multiply this by our arrow force. Okay, so it should be both settings because it's in the serializable class. So we are going to say both settings dot arrow force. Okay, so we are going to apply this force to this game object. Now we are going to apply this force. We are going to say force mode as a dot. Let's apply this as should it be acceleration? Let's say velocity change. Okay, so that will be our force. Then we will do quaternion. Okay, so we'll do current arrow dot transform dot should it be look at or no dot rotation. Okay, and we are going to say this should be quaternion dot look rotation. Okay, so the quaternion look rotation is going to be the current arrow dot velocity. Okay, so we actually going to do this in the update of our arrow script. Okay, inside the arrow script we are going to do it in the update. So we are going to add the update. So with the update added for us, what we are actually going to do is we are going to do this, or let's just do a transform dot rotation. Okay, should be equal to quaternion dot look rotation. So we are going to get a look rotation, and that look rotation is going to be our velocity. Okay, so we have that set. We can save this, and now we can fire some arrows. So now we need to call this function in our input system. Okay, so inside our input system, when we fire the arrow over here where we are actually firing the arrow, we first going to do we are still going to do this, but we are going to also add another function here. Okay, so we are going to call fire in this bool script. Okay, so now we actually going to um, first we need to see if we get a hit point, if we are hitting an object. Okay, if we are hitting an object, we need to move to the hit point. If you are not hitting an object, we need to get a point on the ray, and then like move the arrow to that point on the ray. So we are going to create a boolean over here. We are going to say bool hit detected. Okay, so this boolean is going to actually tell us if a hit has been detected. So in our array cast, if we are able to hit something right here, we say hit detected should be equal to true. That means we've actually detected a hit on an object. Okay, but if not, we've not detected any hit on an object, so we say hit detected should be equal to false. With that one done, we can come here and say and do a check over here. We say if hit detected. Okay, we'll do something, and else we'll also do something over here. So what we are going to do is in our if, when we actually have a hit detected, we are going to access the bool script and then call our fire, and then we need to pass the direction, okay, of travel for our array. So the direction of travel should it should come from, all right, so a small bug here we need to fix. In our bool script, we need to actually take the hit point, okay, not the direction, and then we are going to create another vector 3. Okay, and this vector 3 is going to be our direction. So this is now going to be our direction, and we're going to say the direction is equal to, now we are going to get this arrow prefab over here, the arrow position, because that's the position of our current arrow. So we actually, first we are going to do the hit point minus the bool settings dot arrow position, and that will give us our direction. Okay, so over here all we need to pass is the hit point. So if hit detected, we will say hit dot point, and then we just pass in that. Okay, so I'm going to copy this guy, paste this guy here, and this time instead of we saying the hit point, we are going to say ray, and we are going to get a distance on the ray. All right, so we are going to get a distance on the ray, so we say ray dot get point. So we'll get a point of, let's say 300 units in the forward direction on the ray, and yeah, we have that working for us, the hit detection. So there are some few things we need to do here. Back in our Unity editor, we need to set our current arrow and then add a prefab. So this current arrow prefab selected, let's drag this into the scene. Once in the scene, there are some few things we need to do. We need to correct some rotations over here, some few problems. First, we actually going to rotate these three guys, and we are going to rotate them this way. Okay, so they are pointing in the forward direction. So there are some few issues we will have to tackle. So okay, so what we are actually going to do is we will rotate this 90 degrees on the x-axis, and then with this one done, then we also have to actually create an empty game object. So we are going to create an empty game object and rename this game object to arrow. Okay, with this one done, we will parent our new arrow to this, and then let's reset the transform so it's aligned perfectly. Now you could see this is facing the forward axis. Now we are going to add a rigid body component to enable physics on our game object. So we don't want gravity, so we are going to disable the use gravity, and then we are going to make this continuous dynamic because it's actually moving. Okay, so we want a continuous physics detection on this guy. Then we are actually going to add the box collider component. Now we need to set our box collider to fit exactly on our game object here. So with the box collider component selected, we are going to click this icon here to edit the collider and kind of like drag it down a little bit so it fits precisely on our arrow. So it's going to take some time, so I'm just going to fast forward this. So the boss collider is exactly on the arrow. Okay, so I'll fast forward this and then I'll be back after I'm done, okay, with this. Okay, all right guys, so I'm back, and now we have the collider set up. So you can see I actually have the setup like this. So you can see when an arrow is shot from a bow, you can see there's a pointed edge which gets stuck into any surface, and then there is the other part. So this collider is going to end somewhere here and here. So we don't want the collider to also collide with the player. So the player is going to hold this part and pull and then fire with this part. So what's going to happen actually is this part is going to get stuck in whatever surface, be it a wood, a tree, or whatever. So when the collision occurs at this point, you realize that this will already be stuck into the surface, and its kinematic will be set to true. So the rigid body will no longer be moving. Okay, so with that one done, we are going to create a new prefab. So I have a prefab folder here, so I'm going to drag this and make this into a prefab. So now we have our rigid body component. I'm going to select the prefab and add the arrow component, the arrow script we created. So that has been added also. So I'll go back to my player game object and then look for the bow. Okay, so I'm going to go, and then I think the bow was in the left arm, left forearm, and in the left hand. So we have the bow here. Now first we need to drag the arrow prefab and then drop here. So now we have the arrow prefab set for us. Now what we can do now is to give this a try and see how it actually looks like. So I'm going to delete this one from the scene, and then let's actually give this a try. So alright, so we have it here, but there's some few issues. So you can see it goes and then it collides with the wall. Okay, but there are some few issues. It's actually colliding with something. So it's like it's colliding with the character controller. So it's colliding with our character. So what we are going to do is we have a tag on our character called player. So we don't want it to collide with our player. So the fix for this is we need to do a smart if statement check over here. So on collision enter, we are going to say if collision. So we are getting the object we are actually colliding with, and we say dot game object dot tag. So we are going to say this tag is not equal to our player. So whoever is playing this game we are creating here, if that person's collider is not interacting with the bow, then indeed we can actually collide with those objects. So with this one, you can see if that game object is not tagged as player, then this can take effect. So we can save this, go back into our scene with the changes taking effect. We can try this out again and see how it ends up. So now you can see we don't have that weird behavior again. We can fire some arrows and then it actually gets stuck on the surfaces. Okay, so there are some few issues here. So when it gets stuck on the wall, it actually rotates backwards to its like original position. So we need to find a fix for that. So everything looks good, but just this. So you see when it hits the surface, it rotates towards this again, because what is happening actually is in our arrow we are actually doing rotation in the update. So now what we are going to do is, when the collision occurs, we are going to have a boolean over here. So we are going to say bool disable rotation. So we need to stop the rotation. So we are going to say when we hit an object, disable rotation should be true. Okay, so sorry, disable rotation should be true. Okay, so if not disable rotation, so if we have not disabled rotation, then we want to actually rotate. But if we collide with an object, automatically disable rotation will be set to true, and we wouldn't be able to rotate based on the velocity, because when we set the body to kinematic, it means there is no physics affecting the rigid body. Okay, so what happens is there is no movement, there is no force, there is no velocity affecting this body. So the velocity is reset back to the identity velocity, which is 0. So the velocity is reset. Sorry, is it identity? I don't think it's identity. The velocity is reset back to like 0. So it means there is no velocity on this object. So it rotates back to like a 0, kind of like a 0 velocity. So let's play this again, and then let's see. Okay, yeah, so now that has solved the problem for us. So you can see now we don't have the rotation resetting itself. So when it reaches, it keeps its rotation, the rotation at which it was traveling with, and then gets stuck into the surface. So you can see we get the arrow sticking through the surfaces. So in order to make this guy a little bit perfect, we can also look at how the collision is occurring. So let's drag the arrow here, and then let's zoom on this guy. Now in order for the collision to look really perfect, we need to align the box collider very well, so the collision looks neat and then perfect. So this is more of like unity physics. So if you don't really understand unity physics, I'll advise that you spend some time, read about unity physics, and then you can come back and then watch this video over and over again till you get it right. Okay, so I'm kind of like trying to make this a little bit smaller so the collision is better off, and I want it to stack more, like it should go deeper into the surface it is actually colliding with. So yeah, so that's that. So I'm going to do that quickly, and then I'll click on this overrides, and I'll apply all. So I'll apply my changes to all instances of this prefab, of this arrow game object prefab. All right, so now we have like this setup looking good. Now we can shoot some arrows, and then the arrows fly out and then hit a surface, so it's and get stuck on the surface. Okay, so there we go. So you can see looking good, nice, and yeah, so this is a good setup we have here. Everything is working as it should. Okay, so yeah, so that's that. So now I want to do some few fixes. The first thing I want to do is our crosshair. I'm going to drag our crosshair prefab also back into the scene. Let me delete this arrow prefab. Now with our crosshair selected, I'm going to increase the scale of the crosshair. It looks too small for me, so I'll increase the scale a little bit, and then I'll just apply all the changes to the overrides and then disable it, and then let's see how it looks like when yeah. So it's okay, a little bit better. Let me increase it more. Let me uh, scale it up a little bit, and then let's apply again, and then let me disable this, and then let's see how it looks like once more. Okay, so this looks good for me. um, yeah, so now the crosshair looks better. Okay, so now we can shoot some arrows. All right, so let me delete this crosshair now. Now everything is looking good, and also I think we need to do some head rotation. So in our input system, we actually had head rotation settings. We did a spine rotation where we could rotate the character spine. So let's see how to programmatically uh, do the head rotation. So first we are going to call the animator IK function, which is a Unity built-in function. So on animator IK, now with our animator IK enabled for us, we are actually going to set some IK properties. Okay, so now on animator IK, we are going to say if the character is in the aiming state. So if it's aiming, so we are going to do some few things else, and we are going to have an else. So if the character is not aiming, we're also going to do something. So first thing is we are going to get the animator component, which is the anim. So I don't know whether we have the player animator over here, whether we are getting the animator component. So okay, so we need to make a reference to that over here. So we are going to say animator, and then we are going to say anim, or let's say player anim. So the player animator component. Now with that done, the next thing is to get the player anim component from the get component call over here, and we are going to call this function animator. We are going to call this component animator, and then we are going to require this component anytime this script is created. So I'll just copy this line and then do the same over here. So require component type of animator. So anytime the script gets added, we want to automatically require our animator. So now we are going to say player anim dot. Now we are going to set the look at weight. So look at weight is actually a float from 0 to 1. So it's a decimal number from 0 to 1. So now if we are actually aiming, we are going to set the look at weight to 1, and then we are going to do player anim dot set look at position. So we want to set the position the player is supposed to look at. So we'll do array dot get point. So we get a point on our array, and we did a look at point in up here in the head rotation settings. We had a look at point set up for us, so that is that. So this is the look at point we have set over here. The next thing is to do a player anim dot set look at weight. When we don't actually aim, we want to set the look at weight back to 0. So that means we don't want to actually look at any target at all. So with this one down, let's say, and the player head rotation should actually work automatically. The player should be able to look at the target she's actually aiming at. So this one done. So looks like it's not working yet, because we have to go to our animator here. Inside our animator, we are going to add IK to the animator. So let's add the IK to the upper body. So we select the settings icon here. All right, with that one selected, click on this IK pass over here. So we select IK pass, and then it enables IK on the upper body layer. All right, so go back to our scene and then play again. Now with play, now you can see she rotates her head up and down and looks at the uh, target. Okay, now you could see she kind of like tilted her head towards the right too much. It's like she's not really looking at the target. So the fix for that is to set the look at point. So we are going to enable test aim, and then yeah, so you could see she's looking at the point in a weird direction. So what we are going to do to fix this is to drag the look at point a little bit forward or backward, so we can get a good position for the character to look at. Okay, so let's just do that, and then now let's see. Now I think 2.47 sounds like a good value for the character, and she's kind of tilting in a weird way. So we still have some problems. Let me see. So I'm still going to play with this value so I get the right value for the point the point the character is supposed to look at. So this is weird. Let me set this. So all right guys, so apparently now the fix for the head rotation, we need to do some just one change in the script. Let's go to our input system. You see we setting the lookout weight position for the head, okay, to look at. We also going to do one change, and that is we are going to rotate to cam view, okay, in this rotate spine. Okay, so once we rotate the spine, we also want to rotate to the cam view also, okay, and that will fix the head rotation so it doesn't look weird. So let me replay this, and then we will see now the head rotation of the character looks good and perfect. So you see she looks up and down when we actually aiming at the target. So we can fire, you can see. So currently we need to do some fix on the bow. I see we are using velocity to actually move the arrow forward. Okay, so what we actually going to do is go back to our script, and then in our arrow should it be our bow script here where we have the force mode, we are applying our velocity change. So we are going to change this to actually force. All right, so velocity change applies an instant force. So the force is just applied once and that's all, but when we apply a force, it's a continuous change. So the force is continuous and it runs over and over again. So we have our head rotation fixed. So let's go back and then see the bow script. So this, now you can see we have a continuous force being applied. Now we also need a fix that is traveling very slow. Okay, so we go to our bow. All right, we select our bow and we have the arrow force, okay, over here, the amount of force to actually push this arrow forward. So we are going to set the force to like 25. Let's see, with this set to 25, let's see what happens. So does it look good? So you can see when we shoot in the air, the arrow gets stuck at a point. It should actually go be continuous. So we are going to also fix that. So now we have the changes made, so we can shoot the arrow. We can also, let's keep changing this value. Let me say 60 for the force amount. So force amount of 60. I think I'll take it a little upward to like 80. Okay, so give a force of 80. I'll still go up a little bit. I think 120 will be cool. Yeah, so when we come out of play mode, we just have to input the force amount. So I'm going to say 120. Okay, so with that one done, there is another thing we need to do. Let's go back to our script. In our arrow script, we have to get destroy the arrow after some amount of time. Okay, so we are going to create a public float. So public float, a float variable, and we are going to say destroy time. Now destroy time is responsible for keeping our scene clean at all times. So we are going to set the destroy time to, let's say, after 10 seconds we want to destroy this game object. So in our start function, we are going to call destroy, and then we are going to say we are going to destroy this game object. So we'll do this, we are destroying this, and then we are going to do this in destroy time. So after 10 seconds we have to destroy these things from the scene, so our scene looks very clean. If we don't do that, we don't destroy this from the scene, we will actually be losing a lot of frame, okay, a lot of frame rate. So the game will begin to run slow, which means there are a lot of game objects in the scene that needs to be cleaned up. So with this done, can fire the arrow and see it's working perfectly as it should. And then so let's wait and see if this game object gets destroyed after some time. So after 10 seconds this shouldn't be in the scene anymore, they should all be destroyed. So let's see if they get destroyed. So 10 seconds should be up by now. So I'm shocked. Why are they still here? So okay, so the problem actually is we are destroying the script but not the game object. So we have to do this dot game object. So we destroy the game object itself. So we actually destroyed the script, but we didn't destroy the game object. So we'll go back and then play this. Now let's see what happens this time. For some time we have to destroy these guys from the scene. So you can see we have some arrows. So after 10 seconds, so you can see they are getting destroyed. So we are actually now destroying the game object. So you see this is gone and this is gone. So we can destroy the arrows after some set amount of time. So that said and done, we also have our head rotation perfect. She looks up and down based on where she's supposed to throw the arrow to. So we have this working for us. So now everything looks good for me. I think now everything is really good. Okay. Is there an object this is colliding with? So yeah, so we need to actually see our raycast. So when we go back to our player, we set the aim layers, only the default layers, and let's see our player. So we are going to create another layer for our player. So we are going to say add layer, and we are going to rename this layer to player. So we don't want to also collide with the player, so we are going to say this is our player layer. We are going to change all the children of our player. Now our player just left the scene because remember in some previous videos we set the UI camera and the main camera to actually include some layers. So we need to include the player layer to the main camera so it renders the player. Okay, so with that one done, we have a player being rendered, and then we also have to do something with the UI camera selected. You can see in our console where we enter play mode, we get this error. There are two this warning over here. There are two audio listeners in the scene. So with this over here, for this we have to take the audio listener away from the UI camera. So we are going to remove the audio listener component, remove that component from the UI camera, so we don't have that error. So we don't have two audio listeners in the scene. So with that one done, we know that our array wouldn't be colliding with our player, wouldn't be interacting with the bow and arrow, so we can travel to the desired position. Okay, so here we go, everything working fine, and fire arrows. Yeah, so there we go. So you can see now we can fire some arrows. Okay, so have this done for us. Looks good. So yeah, so now think some of the arrows sticking in the air, so it's, I think the ray is also colliding with some other objects. So and I think the ray is actually colliding with the arrow itself. All right, so we are going to open the arrow prefab, and we are going to edit this prefab. We are going to add another layer to this prefab. Now we are going to add a layer called this is not going to be a player layer, this is going to be like arrow. So we don't want the arrow to also be receiving the ray from the camera, so we are going to set this to arrow, and we are going to change all the children. Okay, after changing this, we have to save the, so the prefab changes, so will be saved. So we have the prefab set to arrow layer. Okay, so the arrow doesn't collide with another arrow. Okay, so when we have that arrow in the scene, it doesn't collide with another arrow again. So there's something wrong. I don't know why. Is it a change we just made in the prefab? So the reason our arrow is not showing is in our main camera we also have to add the arrow layer so the camera can render that. So when we enter play mode in the scene, now yeah, the camera can render the arrow now, and you can see our arrow is rendered for us in the scene. So there we go. So we have everything working as it should. So we are firing some arrows, doing something cool here. Okay, so now so we have a problem. It's like when we aim very far, it actually doesn't travel to the point it's supposed to travel to. So I don't know what is causing that. I don't know what is giving us that weird but when you aim very close, it goes and gets stuck into the surface. When I aim this way, so let's see what could be the problem. Aim very far, it travels just this short distance, and then let me select my arrow prefab here, and let's see if we can get a fix. So we said the this is continuous dynamic, not speculative. So let's set this guy to continuous dynamic. So I'm shocked why it it was set to speculative, because we actually set to dynamic. So now let's try it again. Okay, so yeah, so we fixed the error. So we had to set the the arrow prefab, the rigid body component to continuous dynamic. All right, so the collision detection should be continuous dynamic, not continuous speculative. So that was our error there, and now we have a fix. So I'm happy with this one, and yeah, we have a full bow and arrow system working. There are some few touches. All right, so we actually also have in our bow, we actually have to equip the bow, unequip the bow. These two things hasn't been done, so this is how we are going to do it. So if we had equipping animations for the bow, we could bind that to a key press, and yeah, that would be easier for us. So we'll go back to our scene. In our scene view, select our character here. Now with our character selected, we are going to create an empty game object in the left hand, and we are going to say bow equip pose for the equip position of the bow, and we are going to use a gizmo to represent this guy. And then we are going to copy the component from this one over here, this bow copy component, and then we are going to paste the component values here. So the transform component of our bow, so this is going to store our position and rotation of the bow when it is equipped. Okay, so the next one is we are going to go into our spine, the character spine over here, and then we are going to drag the bow to the spine. Okay, and we are going to reset. All right, the bows transform, and then drag the bow to a position behind the character. Okay, so we are going to drag the bow here, so right behind our character, like this, and we are going to kind of like rotate it a little bit towards this direction, and then drag this down, drag this here. So we have our bow unequipped position. So this is going to be, if the bow is not equipped, we want it to be in this position. So in our spine, we are also going to create another empty game object. So create empty, and then we are going to name this bow unequipped pose for the unequipped position. Now we are going to copy the component of our bow here and paste the component values right here. Now with that one done, the next thing is to select our bow itself, and with our bow selected, we are going to drag the equip pose transform here, the unequipped transform, and then the equip parent. The unequipped parent is going to be our spine. The unequipped parent is going to be our spine, so the spine here, yeah, so got it now. And then the final one is the equipped parent, which is going to be the character's left hand. Okay, so now we have this done for us. We are going to save it now. Now we need to find a way to call these two functions. So we already wrote this script some couple of tutorials ago. So we are going to make this public functions. So public void equip, and then we are going to do a public unequip. Save this. Now in our input system, if we are aiming, okay, if we aiming, now this aim function, we are going to actually call the bow script. So we are going to say bow script dot equip bow. So we are going to equip the bow when we are in the aim state, and then we can copy this guy and we say else. If we are no longer aiming, we do bow script dot unequip bow. Save this, and then now we can play, enter into Unity, replay the game, and then the changes should actually take effect. So now you see our bow is not equipped, it's behind our character. So the character is not holding the bow all the time. So when I right click, she equips the bow, she picks up the bow, and now we can fire. Alright, so that looks good, that looks done. And also one last change we are going to do in our input system is we are going to apply gravity to our character. So let me enter into play, and let's go into the scene view and see something. With our character selected, you could see our character's feet is not like lying on the ground, so we need to apply gravity on this character controller. So how do we apply gravity? So it's simple. We can use root motion to apply gravity with an animation, but we are going to do it a simple way inside the script. So we have reference to we need to get reference to our character controller component. So we are going to create a character controller. We're going to say CC, and down here we are going to say CC is equal to get component. Going to get the character controller component, and once we get the character controller component, we also have to get we're going to create a header here, and we're going to say gravity settings, and then we are going to say public float gravity value. So gravity value, and we are going to set gravity value to 1.2. Okay, yeah, so 1.2, and then with our gravity value set in update, we are going to do a check. Okay, so the check we are going to do is we are going to say right here, we can do the check here, if cc dot is grounded. So we are going to do if cc dot not is grounded. So if the character controller is not grounded, we are going to do so we are going to say character controller dot so we are going to say we are going to call the move character controller dot move, and then we are going to add so we are going to create a new vector. We are going to say vector 3, and inside this vector 3 we are going to say new vector 3 rather. So we are going to say new vector 3. We are creating a new vector 3, and then inside we are going to say our x to be the transform dot position dot x, and then the y is going to be our gravity value. All right, so we are going to do transform dot position dot y minus the gravity value we set. Okay, so I spelled the gravity value wrong. I did gracity, so it should be gravity. So gravity value. So after setting our gravity value, the final thing is to do a transform dot position dot z. All right, then we can save this, and then let's go back and replay. So now gravity is acting on our player. So all right, our player is on the ground, but still it's like she's still not on the ground. So this one is as a result of the character controller we need to adjust some values in the character controller. So let me go back to my scene view, focus on my player. So we don't want her to be hanging in the air like this, so let's recenter the player on the character controller, and then yeah, So there we go. So the fix is to recenter the character controller. So we've recentered the character controller, and then we can copy the new center position, which is 1, and then paste it. So we paste it here, and there we go. Our character controller is fixed. So our player's feet is on the ground, so it's not like she's flying in the air. Okay, so we have a lot of fix done in this tutorial. In the next tutorial, we might finish this with adding sound. Okay, so when she starts pulling the string, a sound is supposed to play. When she releases, a sound, and all. And when the arrow hits a surface, we need to hear a sound, like an impact sound. Okay, so we have this set up. Now we have our crosshair. Our character looks up and down when she's aiming. She can look left and right when she's aiming. Looks good. And then she can also pull the string, release, fire some arrows. So ladies and gentlemen, we built a third-person bow and arrow system here. So in the next tutorial we might do some fixes, see some small errors that are still dominant in this game we have here, and then also we'll also look at adding the finishing touches for like the sound system, the footstep sounds, and all that. Yeah, so catch you in the next one, and spend some time really going through this video. I know the videos are becoming a little bit longer than expected, but there are a lot of things I have to cover here, and I can't do that all in a short video. So yeah, the video tend to go a little way too much. But guys, this is what I want to do. I want to give back to the community, and I want people to like enjoy playing around with Unity. When I tried Unity, it was very difficult to grasp some concepts. So I decided to like create a tutorial like this to help the community. So our advice to you guys, ask questions in the comment section. Let me know what you think. If you have any recommendations, any upgrades you want me to do, I will do a tutorial on that, and then we'll get going. And then also you can also recommend other kind of video tutorials you might want to see. All right, maybe other game play logics you want to see me code, or maybe some game mechanics that you find very difficult doing and you need help. You just hit me up. I'll try my best to see what I can do. So guys, see you in the next one. Bye bye.